When we introduce hardware, we discussed that computers interact with users through input and output devices. Most high-level programming languages provide standard input and output methods for programs to obtain input from users and output results to users for inspection. In Java, the standard methods for outputting text to console are system.out.println and system.out.print. System is a Java class. You have seen println in the Hello World program. The difference between print and println is that println will move to a new line after printing, while print will stay at the same line. Technically, println and print are methods for print stream class. Notice that they are separated by a dot or the dot operator. I'll come back to these when we discuss classes, objects, and methods in the next lecture. There are similar standard methods for input based on the scanner class, but it's a bit clumsy. So we have created a new I/O class called I/O as a wrapper that will combine both input and output and hopefully provide easier to use I/O interface for you. Wrapper methods are used very often in Java. It basically provides alternative interface based on existing methods to satisfy certain purpose. In this case, the new I/O class would hopefully be easier to learn for beginning programmers. I'll come back to the scanner class when we discuss file I/O. The output methods for the I/O class are io.outputLint and io.output. We have seen both of them in the course grade program. The difference between the two is that io.outputLint will move to the next printing position of a new line, while io.output will stay at the same line. The two methods, output and outputLint here, take the character string as parameter and output that on the console. In the case of println, final grade, which is of double type, will be converted to a character string. And the plus sign you see here is a concatenation operator which combines two character strings to a single character string. This will be discussed in more details when we discuss character strings in week 7. The input methods are io.inputInteger for integers and io.inputDouble for doubles. You have seen io.inputDouble when the course grade program asks the user to input exam score, lab score, and homework score. Similarly, io.inputInteger can be used for integer input. In order to use the I/O class, there is one more thing that you need to do. You need to import the package com102x that we have set up for you. In particular, you need to include the statement import com102x.io at the beginning of your program. Import is a Java reserved word. You should see a lot more examples about using import and these I/O methods in the coming weeks. I want to say a little bit more about user interface for input, especially for numbers and text, since that is often needed in many applications. For example, when you go to a supermarket, imagine how long it would take if the cashier would have to input every item that you purchase using a keypad. Notice that not only the prices would have to be input, the store needs also to keep a record of all the items being checked out for every transaction. That is, the name of each item also would have to be entered. Since computers are not very good in reading handwritings, or even printed words, or understand human speech, at least not yet, the technology is improving, but we are still quite far from having systems that could deliver the speed and accuracy requirements for many applications. Alternative input interfaces are needed. Keyboards are the most commonly used input devices. There are alternative technologies, such as barcode. I'm sure that every one of you have encountered barcodes often in daily life. For example, in supermarkets, libraries, and the mails that you receive. Recently, there are also new technologies for voice recognition. For example, Siri that an iPhone uses for voice input. And many of you probably have the experience talking to a computer when you make telephone inquiries, which could often be quite frustrating. Recently, RFID, or radio frequency identification technology, has allowed products to be tracked through wireless non-contact means. Some supermarkets are experimenting with RFID tags that would allow customers to check out without taking out every items from the shopping basket. I'll show you an example of manipulating barcodes in a program. A barcode is a machine-readable representation of data in the form of an image. I'll just talk about one-dimensional barcodes here. Two-dimensional barcodes, such as QR code, are gaining popularity. Basically, a linear barcode represents data by varying the width and spacing of a set of parallel lines. Some examples of barcodes are shown here. Barcode technologies were developed in the 1960s and became a commercial success when they were widely used in automated checkout systems such as those found in supermarkets. The picture here shows a barcode reader. What I want to point out in the following example is that we are using the data abstraction approach in dealing with barcodes. That is, we need only to know that a barcode represents a number as a series of digits, and a barcode reader will be able to decode the barcode and input the number to a computer. How it's actually done or implemented is not important to the user. You could just treat it as a similar way as numbers entered by a keyboard. The program here demonstrates that simple arithmetic can be applied to numeric values represented using barcodes. The program begins by import the I/O class from the COM102X package. In addition to performing I/O from standard input and output devices, the I/O class that we define for you can also accept input and output numbers as barcodes. This example is to illustrate that as far as the computer is concerned, there is not much different whether the input numbers are obtained from the user through a keyboard or a barcode. The detailed representation is not important as long as methods are provided to the program to decode the information. Like before, the program is given a class name, in this case, barcode demo. Main is the entry point to the program. The first part of the body of the program accepts two barcodes as input using the method input barcode from the I/O class. You will see later in the demo of the program that instead of entering numbers using a keyboard, the user will be asked to select a barcode image which represents some number from an existing file. The number would then be decoded and assigned to the variables value 1 and value 2. This is similar to the use of input integer or input doubled if the inputs were to be entered from the console terminal. The numbers entered through the keyboard would still have to be decoded before assigning to the corresponding variables. Notice that we use the type long here because barcodes can represent very large numbers which could be out of the range of int. Once the barcodes are decoded as numbers, they can be used the same way as they were created by other means. The two io.outputInt statements here output the values represented by the two barcodes. The values can then be treated the same as the numbers represented in other primitive types in Java, and arithmetic operations such as addition and multiplications can be applied to these numbers. In this case, the results of the operations would be assigned to the variables add results and mult results with the primitive integer type long, again because barcodes can represent very large numbers, and the results of the arithmetic operations are printed out for inspections. Alternatively, the results could also be output as a barcode using the method output barcode for the I/O class. In this case, a barcode will be created for the valued add result and stored as an output file. What I'll show you next is the actual execution of the program.